Hello, this is Module 4, Investigation 6, Compounding Periods and Compound Interest Formulas. We are learning about interest at this time. So, when we deposit the money in a bank, they pay you interest based on the balance. It's the money that you invest. The interest can be paid in many different ways, such as once a year, twice a year, once a month, and etc. By convention, bank calculate the interest rate per compounding period by dividing the advertised annual interest rate, often called the annual percent rate of or APR, by the number of the compounding periods in 1 year. Note that this is a different technique from the determining partial growth factors. So number one, suppose you are going to invest $1,000 and you have three choices on how to invest your money. And in all three situations, the annual interest rate APR is 8%. So the first account advertised 8% APR compound annually. And this means that at the end of each year, 8% of the current balance is added to the value of the account. So what is the interest rate per compound period? Which is the interest rate is 8%. And then complete the following. So we want to know 8 compounded and annually. So number of the years since the investment was made, the value of the investment is dollars. Okay, so you're starting with 1,000, and then you got 1,000, but it stays 1 year, so you got the interest from the 1,000 as 0.08, and then it becomes 1080. So that's the money you have. And also now it's the second year. So now from the 1080, and then you're getting an interest of the 8% from the 1080. And then you get the $1,166.40. Now, what about T year? So we need to kind of find the patterns here. So as a pattern, actually the money that you put it in, which is 1,000, and then each year 8% increase, but also you earned 100% that you put it into. So the growth factor will be 1.08, and then it's with the t power. Okay, and then number 3, what is the annual growth factor for this account, which is 1.08? Okay, and then interpret the annual growth factor in the context of this problem, right? So because you still need to earn the 100% from the previous years, right? All right, B, second account advertised 8% NPR compounded semi-annually, which means that the interest is added 2 times per year. So every 6 months, and then you getting an interest, and then the interest added to the principal. So in this case, what is the interest rate per compound period? Which is compound period is 2 times a year, so each period is going to be 4%. So for the compounded semi-annually, so yeah, at the beginning was 1,000, but this time 1,000, and then every 6 months you got 1.04, which is 104%. And then the 0.5 is 1 month, the 1 period, okay? So first period, you got the 1,040. And then the 1,000, 1.04, so every 6 months, right? And then the 1 year means actually the what? Period 2, right? And then you get the 1,080, 1,060. And then the second, so how many of the 6 months in the 2 years? 1.04 to the fourth power. And then it's going to be 1169.86. And then for the t, so 1,000, 1.04. And then you just need to put the 2t because you earn the money for every 2 years. So you got 1,000 For if you power 2 with a 1.04 becomes 1.08 to the 10th power. Okay. It cannot be the same. Sorry about that. So 1.04 to the power 2 is, oh, it's a little bit more. So I want to add it more here. So that's, okay, it looks like the same to me. 0.816 to the 10th power, okay? So your, actually the rate is little, compared to this and then this is a little higher, right? So you'll be making more money actually for that. So what is the 6-month growth factor is? Yeah, 1.04. All right, let's look at the next page. So in the next page, now what is the annual growth factor of this account, which is every year, so it's going to be 1.04 and then 2, right? So it becomes 1.0816. All right, and then number 5, the annual growth factor compound in the part 4 to determine the annual percentage change of the account over a 1-year period. This percentage is often referenced as the annual percentage yield APY. So if you change that, it becomes 8.16% as APY. So this is actually the percentage of the interest. Okay, so see, the third account has 8%, but it's going to be daily. So we did just the simple interest at the beginning, and then we got the compound interest and the semi-annually, now compounded daily. So daily means we have, let's think of, we have a 366 days, but this time I want to think about it as a 365 days, okay? So what is the interest rate per compound period, which is 1.08. Oh, yeah, I have to divide, sorry about that. So this time, the 8%, right? For 365 days. Okay, so it's about the 0.000219. So that's the daily interest rate. Okay, so 0 year is about 1,000, and then 1 day for the whole year, which is gonna be the 1,000 of 0.000219 to the power 1, which is 1,022. And the second day, so 1,000 0.000219 square, which is gonna be 1,044. And then for the first year, which is 0.000219, which is about 365 power, right? That's how many days in a year. So 1,083.21. For the 2 years, which is 0.000219, and then 365 times 2, which becomes 1173.33 cents. Then as a formula, 1,000, 0.000219, and then you can put the you can put the for the T is actually the number of the days or number of the years. It depends, okay? So, but if you put the T, 365T, okay? Or you can just use the 1,000 of 1 point, 0.8321 as a T2, which is, this is makes the annual annually, okay? So what is the daily growth factor for this account? The daily growth was 1.000219. And then what is the annual growth factor for this account to interpret the annual growth? So which is going to be the 1.000219 to the power 365, which come out as 1.083321. And then you use the annual growth factor computed in the part 4 to determine the annual percentage yield. The APY is going to be 8.321%. And then which of the account would choose you the investment justify? I want to say the third account. So account 3. Okay. All right, let's go to number 2. A bank offers the annual interest rate of the R compounded n times per year, where R is the APR expressed as a decimal. Let A be the initial value of the investment, and then define a function G as determine the value of the investment B in terms of the number of years since the investment was made as a T years, okay? So I want to say G of T is, okay? So you're going to have always the initial amounts, okay? And then it's going to be growth factor. So you're adding the always 1 with the interest rate. And then there's the interest period per year, okay? So, and then the always interest period, you need to multiply by T, which is, yeah. Okay, so, but, so which means A is initial amount, and then initial amounts, and then the R is annual interest, and then T is the number of years, and then N is interest period. So annually means n equal to 1. Semi-annually means n equal to 2. And sometimes quarterly, n equal to 4. And monthly, n equal to 12. And weekly, that's a possible way too. That's 52 weeks. And then daily is n equal to 365, okay? And then we can go further if you want it. All right, let's look at the next page to do the number 5, okay? So since I introduced the interest period, a deposit 5,000 in May is made into account paying APR of the 5%. Determine the amount of the account 10 years after the investment was made if the interest is compounded. So I'm using the G of T, which is A times of 1 plus R over N to the nth power. So you got to remember this formula, okay? So annually means n equal to 1, right? And then there's a 5,000 as A. There's a 5%, which is R, which is a 0.05 for 10 years. So T equal to 10. So everything is a given. But N is a change, okay? So annual means n equal to 1. Monthly means 12. And weekly means 52. And daily means 365. So what you need to do is you plug it in. So 10, and the T, just about 10 years, right? So A was 5,000. 1 plus 0.05. So annually means N is a 1. And then we don't really need the parentheses here. Sorry about that. Okay. And then 1 times of 10th power, which becomes $8,144.47. Now the monthly, about 10 years, 5,000. 1 plus 0.05, but it's going to be the 12 times 12 times a year. So 12 times 10th power, I got $8,235.05. And then G of 10 for 5,000. 1 plus 0.05, but this is a 52 times a year. So 52 times 10, which is you got $8,241.63. And then G of 10, which is still 5,000. 1 plus 0.05, but 365 times year. So 365 times 10. And then you got $8,243.32. So as you noticed, if the interest rate is, if the more interest rate period, and then you get more money, even though you start with the same amount of money. All right, that's all. Thank you for listening.